right, so now I've mentioned to you that if you do go out here to the 143 folder by the end of the period today, I'm just producing the one I just finished, but this is a lecture that I came in on Saturday and did. It's about an hour and 5 minutes, and it goes through all the major things that are in Chapter 7. All right. That said, what I wanted to do is just take a couple minutes. I'm going to run through these, and we're going to go through them at almost warp speed because it's 11:15, and I want to finish by 11:30. All right. Now, one thing is, everything we've talked about so far has been arrays. Java also supports something that's called the array list. The difference between an array and an array list is an array is set at compile time, so you cannot change the size of an array once the program starts running. And that's the same in Java and in C#. But an array list, or what's just called a list in C#, they can automatically expand and contract based on what you have inside of them. All right. For right now, we're concentrating on arrays. Now, the big thing there is some of the useful array algorithms and operations. We've already gone through those. Adding up the elements in an array, figuring out the average array element, figuring out the largest array element, figuring out the smallest array element. And I just literally took the stuff that the author had in the book there to try to be consistent. All right. You can create an array of anything in this language, including an array of objects. So I could create an employee object, and then I could create an array of those employee objects if I wanted to do that. They start talking in here a little bit about searching, two-dimensional arrays, three-dimensional arrays. This is new, command line arguments, and then it ends with the array list class. All right. What we've talked about virtually, forgetting about strings for a second, but this semester we pretty much have concentrated on int, short, long, byte. Those are whole number variables. All right. And byte should have been really at the beginning, because a byte is just something that's typically is 0 to 255 as far as its length. And then we've talked about float a little, and what we've usually used double. All right. And then there's also char, and there's also boolean. And if you add those up, that comes up to 8. Those are the 8 Java primitive data types. You can create an array of any of those. You can also create your own object and then create an array of those. So, basically it's your own imagination is the only thing that holds you back. So those are primitive values. Again, arrays allow us, rather than having, again, you saw this in the last class, those of you who were in there, and that's most of you, that if I create an array and I put, let's say there's 25 of you in the class, or just like we just did with the random numbers, much easier to create that array of random numbers than to have num1, num2, num3, num4, and have 25 of them. So as it says, it allows you to create a collection of like values that are indexed. All right. Now, again, is this an important thing? I just want to mention this to you because sometimes you see this kind of stuff. You can set up an array like this, or you can do it like this, or you can do it like this. Oops. Java doesn't care which way you do it, okay? And why am I showing you that then? Because see this way right here, this last one, you must do it like that in a class you'll take next semester in the C class. You have to set up arrays like that. But Java is a lot more lenient. Most of the time you'll see people doing it one of these two ways. I always do it like this. All right. So you can declare an array and give it a size at the same time. Int bracket bracket numbers equals new int 6. So the elements in there will be numbers sub 0, numbers sub 1, numbers sub 2, etc. And as long as you get that, there's not much more to this section in here to get. So again, if I come through here and do this, all right, that's as if I came in, I can do this, but if I know what those numbers are already, so let's say that I know they're the numbers 1 through 6. I can do that and put them inside of curly braces like that, just like you saw in the last class. In fact, let's make it 0 through 5, so it looks a little bit more reminiscent. Now, I can do that, but if I want to, I can take all the time to type in numbers 0 equals 0, and I can do that 5 times also. So if you know ahead of time, if you know what the values are going to be, it's much easier, makes it easier for the compiler too to do it like this. All right, that's the advantage. And notice when you do it like this, you cannot put a number in here. All right? I shouldn't say you cannot, you should not, because you're letting the compiler count how many elements there are in the array. This is literally read numbers sub 0, sub short for subscript, equals 0. So that says take the number 0 and assign it to the first array location. All right? And that's what they talk about in much of the book in here. Again, arrays must be of the same type. That's not the rule in JavaScript. That's not the rule in PHP. That is the rule in Java. That is the rule also in C#. Sometimes they just talk about that you use a constant, and that's fine. I already mentioned that to you. They give you some demos in here. All right. Again, array indexes always start at 0, and they go to the array length minus 1. So you saw this, those of you who were in the last class, that if I come in there and do something like this, so if I come in and say int bracket bracket numbers, all right, equals, and let's just say, we'll give it values. I'll just make it real simple. 0, 1, or 0, 2, and 4. That's fine. 6, 8, the even numbers between 0 and 10. How's that? All right. Well, if I come through here now and I say 4 int I, we'll keep it I now, equals 0, and we say I less than numbers dot length, I plus plus, well, the system's smart enough that it counts, and it says there's 1, 2, 3, 4, 5 elements. And the first one is element 0, and the last one would be element 4. But a mistake that programmers oftentimes make is they say this. So instead of going from 0 to 4, it goes from 0 to 5. And that's bigger than the name that you saw last hour. That is an array index out of bounds exception. So if you ever get one of those, that's going to be why. You've got at least an off by 1 error. And there they show it. Okay, I guess I should have just used the one that was in there. I already shown you this, how you can set that up. All right. Again, brackets can go in either place. Once you've done that, if I start using my array like, okay, I'll get it right there. Give me 3 times I can get it right. Once I start using my array like this, those are just variables. So if I pass one of those into a method, what am I doing? I'm passing something in by copy. If you pass the whole array in, you pass the whole array in by reference. But if you just pass in an element, you're passing in a copy of it. All right, a lot of times people forget that. But now I could just treat it like any other variable. So I can come up here and I can say, for instance, numbers sub 5 equals numbers sub 2. What does that do? I'm asking you. What does that do? No. You had a good start. It assigns the number what? Number 2 to that location. And I can come through here and I can say it equals numbers 2 times 156. I can do that. Then it's going to take that value, which is 2, multiply it by 156, and take 312 and put it in that array locations value. So you can start to use them then like just, quote, regular variables, unquote. All right, and That's what the author talks about in here. All the stuff like pre-increment, post-increment, all that stuff works the same. You can use them in relational operations. You can use them in conditions. We already talked about the length. You should always use length. You should never put a hard-coded number in there, ever. There's not a reason to do that. There's also this enhanced for loop. All right? So take a look at this. There's a mistake on the slide here. It's a lowercase f, not an uppercase f. All right. See that? That's another way of doing a for loop. That's called the enhanced for. And it's for and then int. You're creating that variable right on the fly. Colon, the name of the array. But if you use this enhanced for loop like this, you can't change the value of any part of the array inside of the curly brackets. If you want to change the value of the array in here, then you must use the regular for loop like I was using. All right, we already talked about size and the off by 1 error, so I'm not going to get into that anymore. Okay, if I do this, you saw this, those of you who were in the last class, if I do this, I'm going to get rid of all that stuff here. And I come in here and I say now int bracket bracket numbers 2 equals numbers. That does not create another array with this stuff in it. What that does is this is now an alias. This is now an alias for this. They both point to the same thing in memory. So if you want to copy one array to another, you've got to copy it element by element. All right, and that's the way it works in most every programming language. He shows you that here. Talks about copying, just what I mentioned. If you pass an entire array to a method, you pass just the name, but notice again, when you say it in here, the type bracket bracket. You can't put a number in there. All right. Comparing, you've got to compare them element by element. All right. The useful operations, we already found out the highest. We did the lowest. We did the sum. We did the average. So you've already seen those. You can use what's called a partially filled array. As it says, typically if the amount of data that an array must hold is unknown, think about it. Let's pretend for a second I had 3 classes. I was at a university, and I had a study group that had only 10 people in it. I had another class that only, that was a sub-study group or something that had 50, but then I had a lecture class that had 500. If I wanted to have one array handle all 3, I could make it 500, but then I'm wasting a lot of space for the other 2. But what you can do is just, you can use what's called a partially filled array. They're not used that often. There's nothing wrong with them. All right. Arrays and files, you can get your input to an array from a file. You can write your output from an array to a file. You can use an array for both input and output. The program that you're going to do, the one that you're assigned, has a list of numbers in it. It's got about 12 or 13 numbers in it, and you're going to run through that list using the file and give me the biggest number, the smallest number, the average. All right, the same kind of stuff, I think, in the sum. Same stuff we just did. You can return an entire array from a file. When you return it, it's just the name of the array. You don't use brackets, parentheses, or anything else. You can have an array of strings. So that would mean name sub 0 is Bill, name sub 1 is Susan, name sub 2 is Stephen, name sub 3 is Gene. Okay. And as it says, when you create that, if you don't give them values, they're all set to null. So what they showed you right here, that on that line that you see right there is the same thing as doing this. Is there an advantage to doing it the second way? None that I can think of, because it's more work. These are some of the things that you can use on array elements. You already know that 2 upper and 2 lower case. You can use compare to, you can use equals, and you can use charat. And they give you some examples of them. All right, we already talked about the length field. Again, if we created our own class that was called inventory item, we could create an array of inventory items that were called inventory, and then fill them up. And what you get there when you do this is these become, for lack of better words, pointers over to here. You're not supposed to use the word pointer with Java. Java doesn't like that. They're saying, no, we're better than C. We don't use pointers. Yes, they do. They just don't let you manipulate them. That's the advantage of C over virtually any other language. Because what a pointer is it stores an address of a memory location, and you can manipulate pointers in C directly. It's one of the few, if not the only language where you can do that. All right, search algorithm. Again, I got rid of that, but if remember those 25 numbers we had before, they weren't in any order originally. If I wanted to know if a number was in there, in the worst case, I'd have to search through the whole list to find out it's not there. In the best case, it would be the first one I was looking for. So normally when you do a sequential search, you have to look through half the list to find, on average, find what you want. It's very slow. And if it's not there, typically you return -1 to show the absence of a value. With a selection sort, and again, you saw this in the last lecture, those of you who were in the last class, but they showed you something like this. All right, you've got 5 numbers in here. 5, 1, 7, 2, 8, 3, something like that. With a selection sort, you look through and you find the smallest number right there. And then you flip it with the other one where it's positioned. So that's at the beginning, and that's 5, 7, 8, 3, 2. Then you go through it again, but you don't have to figure out the first one. You already know that's 1. So you say 7 and 2. So now you got 2, 8, 3, 7, 5, etc. And you iterate your way through there like that. All right. That's a selection sort. It's better than that sequential sort we looked at before, but it's still slow. Right? There are whole books that have been written on different sorting and searching algorithms. You can buy, I mean, thick, hundreds of pages. All right. Those two were sorts. This is a search if you're looking for something. With a binary search, it's called a halving, H-A-L-V-I-N-G. So again, if I've got 5 numbers, imagine there were a lot more numbers than this, but we'll keep it simple. We have 5 numbers. All right, and I want to know, remember I'm a computer now, I want to know is the number 37 in there. So what I do is I go halfway in here. I'm sorry, in order to do this, I have to sort this first. So we've got 0, 4, glad I picked something simple, 23, 56, and 78. So we go halfway in. Is that the number we're looking for? No. Is the number we're looking for greater than that one? Yes, it is. So in one guess, I've already eliminated 0, 4, and 23. So I cut it in half again. I say, there it is. Okay? Is it there? No. And I know in 2 guesses it's not there. That's a very good searching algorithm to use. It's very quick, but it requires that the list be in sorted order from the get-go. All right. You can have arrays of multiple dimensions. This looks a lot like a spreadsheet, except with a spreadsheet, that cell is cell A1. Here it's cell 00, and you always say the row first. So that's row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, etc. All right. When you set up a multidimensional array, you need as many sets of brackets as dimensions. How many elements are in this array right here? You should be able to tell me like that. What? 12. Why 12? 3 times 4. If it was a 3-dimensional array and that was 3, 4, and 5, there'd be 60 elements. 3 times 4 times 5. You can have an array of as many dimensions as you want. Most of the time, people don't have an array that's more than three dimensions because it's hard to write an array for something you can't visualize. If you can visualize in 4D, you shouldn't be here. All right? Notice that when you start to fill arrays, so if it's 2 dimensions, you're going to have 2 for loops. 3 dimensions, 3 for loops. So how is this doing? Row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3. Row 1, column 0, row 1, column 2, row 1, etc. The initialization looks a little funky because you got curly braces and curly braces. You can set it up in different ways, and they show you some of the ones you can use here. The length, Notice if you've got a two-dimensional array, as it says, technically it's an array of one-dimensional arrays. So the length gives you the number of rows, not the number of columns. All right, so there's a little bit more work you have to do, and he goes through this. We're not going to do anything with multidimensional arrays this semester. All right. You can have ragged arrays. What's a ragged array? That means that you don't put a number over there for columns. That means that each row can have a different number of columns in it. All right. Again, are they used often? They can be. It depends on the application. There's a 3D array. Okay. And the last thing, I'll just mention this quick. Throughout the entire semester, if you remember, we've always been doing this. Well, now you know what that means, because that's what we just went over. All right. If I run a program from the command line, literally from a DOS command line, and let's say that I've got a program, and the program's called hello. All right. So I type in Java hello, Java hello, and I put in there Jeffrey, Paul, Scott, and I run it, and it comes back and it says hello, Jeffrey, Paul, Scott. Okay. Then what happens is args sub 0 is equal to Jeffrey, args sub 1 is equal to Paul, and args sub 2 is equal to Scott. Now, why am I even taking the time to show you that? Because you can pass arguments of different types. All right, if I was going to write something, and this is what I'm showing you right now, is this is kind of way like, for example, for Linux, that's how their help system is set up. You pass a different variable number of arguments in. All right, and they can be of different types. Very similar to the example I just showed you. There's also a special thing in here. This is kind of cool. This is a fairly new, fairly recent development in Java. Notice that public static int sum, and you say int ... numbers. Why is that cool? It's cool because you can pass in different arrays of different sizes. And Java will handle them all in the same routine. It'll handle different arrays, but it'll do the same thing with each one of them. It'll add up all the elements. Array lists are the last thing. Again, if you want to use those, it's java.util.ArrayList, and it expands and contracts automatically. Notice the funky syntax. Array list, and then the type inside of angle brackets, then the name, then new array list, then the type again in angle brackets, and then, because technically you're doing instantiation, paren. You can make an array list of anything. So if I made an array list of strings, I could add things to it like this. I could check the size. It's not length, it's size. I could grab an element. Okay. I can use it and run it inside of an enhanced for loop. There's all sorts of different things that you can do with this. I decided this semester not even to go over this any more than the 5 minutes that you're getting right now. All right. You can add things, which automatically puts them at the end of a list, but you can say, no, I don't want it there. You can tell it where you want it to be added. Set means take what's ever in element 1 and replace it with Becky. Okay. Notice that the default capacity is 10 items. But what happens is, if you put in 10 items and you put in an 11th one, it doubles the size. It makes it now 20. If you fill that up and you put in the 29th one, then it puts in 10 more items. But you can set it up so every time, instead of putting in 10 more, you could put in, for example, 100 more. All right. You can store any type of an object, as it says there, in an array list. And they give you a programmatic example. So next week will be lab. Wednesday will be lab, whether you're here or not here. And again, the programs that you're going to be assigned for this chapter so we're coming to close to the end of the class. That ArrayFun program we just did, and page 543, number 12, this number analysis class, which uses the values that are inside of a file but it does the same stuff that we just did. In fact, if you look right here, if I go out to in class and I go out to, I think today, that's the file you use. It's pretty simple. You should be able to tell me which is the largest, which is the smallest, the sum of them, and the average. All right, it's not in your book, but I'm going to take for granted that you all know how to use the decimal format class now, so that you can format all these things to 2 decimal places. All right. That's it. I'm finished. It's actually going to be due 3 weeks from Wednesday. No, not 2052. That's pretty good. Yeah, it's doing 37 years in 3 weeks. There you go. 37 years, geez. I'd be in my 90s. I don't think that's going to happen, okay? All right. All right, so it's due 3 weeks from Wednesday. Wednesday will be a lab, and all of next week will also be a lab. All right? And then 2 weeks from today, we'll start on Chapter 8. That's the last chapter we're going to go through in the book. So we'll go through Chapter 8, a week of lab, and then we're going to have 2 or 3 weeks left. And for those weeks, again, we're going to build a simple Android app as a class. All right? That's all that I